Hello Velociraptors, and welcome to my classroom. For the past couple of days, you have been working on creating topographic profiles, geologic profiles, and topographic maps from ground truth points. Now it's time to take those skills to the field. For our next adventure, we will be traveling to McKinney Falls State Park. Our last excursion took us to Shoal Creek Greenbelt, where we were able to see real evidence of the Balcones Fault, which divides Texas and creates the unique biodiversity we see here in central Texas. The fault also divides the strata here based on age, with the older strata in the northwest and the younger strata in the southeast. This was the evidence used to support the theory that the Balcones Fault is a dip-slip fault, meaning that it moves up and down. However, for this trip, we will not be looking for evidence of faulting. We are going to be looking for evidence of volcanism. As you can see, McKinney Falls is east of the fault. However, it is close to Pilot Knob, an extinct volcano here in central Texas. You might remember locating it on the geologic map when we were investigating Austin previously. While in McKinney Falls, we will be creating our very own ground truth points, much like the ones you saw on the topographic mapping activity. However, this time, they are not going to represent the elevation at a particular point, but the geology at various points throughout the park. You will then use these points, much like you did in the topographic map activity, to create a geologic map of the area. To do this, you will be provided with a handout of the area like you see above, which includes contour lines. You will then use this information to construct a cross-section along the following line. However, before you get started, we need to talk about the location. You will see that the area has two prominent water sources, Williamson Creek and Onion Creek, which merges with Williamson Creek. This waterway creates the falls that pools and gives the park its name. These creeks leave behind deposits just like Shoal Creek. However, they are much older and have been depositing sediment for some time. As we showed you before, as a waterway runs across the land, it downcuts and crosscuts. This is what creates the characteristic V shape that we saw earlier and that you illustrated on your topographic maps. This creates symmetry, where one side of the stream's elevation change mirrors that of the other. Thus, someone can be standing at an elevation on one side, and if they look across the stream, they can see the same elevation. But what does this mean in terms of geology? This creates terrace deposits. For example, let's say we have this ideal cross-section of bedrock and place a stream right in the center. Over time, the stream will shift from side to side due to the change in the stream's flow and the path of least resistance. It will also downcut the bedrock. All this time depositing sediment or alluvium. This is what we observed in Shoal Creek. However, the older a stream is, the more downcutting and cross-cutting occurs. This results in two layers. The most recently deposited, here in orange, is referred to as alluvium. The older deposit, yellow, is called a terrace deposit, which you probably saw when investigating the geologic map of Austin. This process can continue to occur, creating another terrace deposit or several terrace deposits. Two things that we need to pay attention for here is that terrace deposits do not follow the law of superposition, meaning that the lower deposit is not the oldest, i.e. orange in this case. The oldest is on top. In addition, this can create complications in the cross-section when underlying strata becomes exposed, like you see here. To determine the relative age, I would need to know if this is a terrace deposit or not to determine whether to follow or not follow the law of superposition. We see terrace deposits throughout Austin, from downcutting and cross-cutting of the Colorado River, which has resulted in various terrace deposits. A key characteristic of terrace deposits is their oxidation. The older a terrace deposit is, the longer that the rock has been exposed to oxygen in the atmosphere. This results in a much rusty color as the rocks become oxidized. The more oxidized a rock is, the older it is. We will see evidence of this in the field later. In addition, terrace deposits are relatively flat. What use do you think we might have for a large space of relatively flat land? Airports. This is part of the reason behind the location of AUS. For this project, you will first start by taking your virtual excursion. Once you have all your ground truth points, you're then going to interpret your geology of the area. Once you have a geologic map of the area, then you're going to work on creating your own topographic and geologic profile along the A prime to A line. Once you've finished your cross-section and your geologic map, we want you to write a step-by-step geologic history of the area. And of course, you'll finalize it and submit it to me. Of course, I have a video explaining the instructions associated with the project, but first steps first, get to that virtual excursion and reach out if you have any questions.